We can take our compound interest formula and rearrange it to get P, or the principal, by itself. Okay, in order to get P, or the principal, by itself, all we would need to do is divide both sides by 1 plus I to the exponent n. That leaves us with P being equal to A divided by 1 plus I to the exponent n. Another way of writing this formula is P equals A, 1 plus I to the exponent negative n. These two are equivalent to each other. Remember, with our work with negative exponents, we can rewrite this power using positive exponents simply by taking the reciprocal of the power and changing the sign of the exponent. So these two are equivalent to each other. This is the preferred formula to use because it's just easier to substitute into a calculator when it's written in this way. Okay, let's look at some examples. So the first one says, calculate the present value if $1,000 is required in 15 months and the money can be invested at 12% per year compounded monthly. So 1,000 is how much is required in the future. So that means we're looking for the principal or present value. So using the formula that we just derived, P is equal to A times 1 plus I to the exponent negative n. A is going to be replaced with the 1,000 that's needed 15 months from now. I needs to be calculated. It represents the interest rate per month that we're looking for, and to find it, all we have to do is take the interest rate for the entire year of 12% and divide it by the compounding frequency. Compounding frequency is going to be 12 times a year since it's compounded monthly. 12% expressed as a decimal would just be 0.12, and 0.12 divided by 12 gives us a value for I of 0.01. N is just going to represent the total number of months that interest is going to be calculated, and the reason being is because interest is compounded monthly. The total number of months is already given. It's 15, so n is 15 in this case. Now you could alternatively convert 15 months to years and multiply by 12, the compounding frequency, but converting months to years requires division by 12. So when you're dividing by 12 and then multiplying by 12, you arrive at that same value of 15. Okay, now what we're going to do is evaluate using our calculator. And the answer that we would get for the present value is $861.35. Okay, let's look at the next example. It says Amy and Hilda plan to invest money in our RESP, a registered education savings plan, which I'm sure many of your parents have started for you. And they're doing it for their newborn grandson so that he has $20,000 available for his education on his 18th birthday. Assuming a growth rate of 7% per year compounded semi-annually, how much will Amy and Hilda need to invest today? Today is a clue word that you should be looking for the present value. So P is equal to A times 1 plus I to the exponent negative n. A is the amount that Amy and Hilda want their grandson to have in the future, and that amount is $20,000. I is going to represent the interest rate for half a year, because interest is compounded semi-annually, and we can find it by taking the interest rate for the year of 7% and dividing by the compounding frequency of 2 times a year, since there are 2 half-year periods in a year. 7% as a decimal is 0.07, and then when we divide by 2, get 0.035, and that is the number that I will substitute for I. N is going to represent the total number of compounding periods. What we need to do here is take the number of years that they're going to be investing for. So they're going to be investing for a total of 18 years, since 18 years will have gone by since their grandson was born and his 18th birthday, and then multiplying that by the number of compounding periods per year, which will be 2 in this case since interest is compounded semi-annually, giving us 36. So we're going to sub in 36 for n. And then when we use our calculator to evaluate, we will get an answer of $5,796.65. So therefore, Amy and Hilda will need to invest $5,796.65 for their grandson's future. Okay. And let's look at the last example. The last example deals with a discounted value of a debt. So it says Lisa owes $1,400 for office furniture that she bought. The amount is due in 2 years from now. A finance company that the furniture retailer hired will accept payment now, discounted at an interest rate of 4% per year, compounded monthly. How much can Lisa pay today to repay this debt? So again, the word today is the clue that we need to use the present value formula. A is how much Lisa owes, and she owes $1,400 in the future. I is going to represent the interest rate per month, since interest is compounded monthly. And to find it, we're going to take the interest rate for the entire year of 4% and divide it by the compounding frequency. So if it's compounded monthly, the frequency will be 12 times a year. 4% expressed as a decimal is 0.04. When 0.04 is divided by 12, you get a repeating decimal of 0.00333333. So for this reason, we're not going to round this number because it will make a difference in our final answer. Okay. The best way is to sub in 0.04 divided by 12 in for I and enter all of that in the calculator so that the calculator keeps all the digits. Okay. For n, we're going to take the number of years, which is 2, and multiply by the compounding frequency of 12. So 2 times 12 gives us 24. And then entering that into the calculator, we would enter 1,400 times 1 plus 0.04 divided by 12, all of it raised to the exponent of -24, giving an answer 1,292.53. Okay, so therefore, Lisa can pay $1,292.53 today to repay her debt. Okay, and this means that if you're paying a debt off early, you're going to pay less than what you owe in the future. And that's why it's called a discounted value of a debt, because there's a discount on how much you owe if you pay it off early.